Well, good morning, everybody. As you said, my name is David Meza. I'm the Chief Knowledge Architect at Johnson Space Center in Houston. I kind of rotate back and forth between here at Johnson Space Center in Houston, here in DC at headquarters. As they mentioned earlier, I got an friendly email late Sunday night saying one of our guys dropped off. Can you please, I know you're going to be there. Can you decide to give a talk? So fortunately, I had this project I've been working on the last couple of months. I started it. I'm going to show it to you guys. It's still a work in progress, so bear with me. But it's something we've been working on for a couple of years as far as the research behind it. And hopefully it'll give you an idea of what we can do with knowledge graphs within your organization. As I mentioned before, I've been working with Neo4j product since it was back in command line interface type, so Neo 1.0 or something like that many, many years ago. And I'm excited to see some of the new things that they're bringing up, especially the multi-instance databases within in 4.0. I think that's going to be an exciting time for being able to use graph databases within your organization. So really quick, when somebody asks me, okay, what's a knowledge architecture? What do you do with a chief knowledge architect? It's the first question I usually get. And cameraman, I walk, so you're going to have to follow me. As a chief knowledge architect, my main priority is to develop and implement a technological roadmap that allows us to turn our data into what I call actionable knowledge, something that we can utilize. So knowledge graphs are a basic concept that I want to try to introduce. If you guys probably heard about it, it's been kind of a buzzword over the last year and a half. But I want to break down one specific project and one specific set of information that we deal with on the International Space Station. But first off, I want to start off with this quote I usually do with Peter Drucker. The most important contribution management needs to make in the 21st century is to increase the productivity of knowledge work and of the knowledge worker. He said that back in 1999. I think it's even more important today, especially with the amount of data that we're seeing in our organizations, the growth of data that's coming out there, the terabytes and terabytes and petabytes and zettabytes of information that we're starting to see. We need to be able to actually utilize that information. Why is that? Because we face an enormous amount of challenges. 46% of our workers can't find the information they're looking for about half the time. We're constantly trying to develop ways of searching and finding information. If I had a nickel for every time somebody's asked me, why can't we just do in our organization what Google does? I'd be a very rich man. Unfortunately, that type of solution does not work in the enterprise. I've said this over and over again. I've said it in front of a room with Google people into it, and they kind of shook their heads. Yeah, we know it's hard to work. And really quickly, I'll tell you my opinion as to why. Those type of algorithms require you to be able to index everything. We don't index everything in our organizations. I know at NASA we probably index 1/10 of our known data. That's our known data. And with that, we don't have as many queries as Google has. Google has 5 billion queries a day, and I think that was back in 2016. They probably have more than that. At Johnson Space Center, we had 1,000 queries a day. And my data scientists in the room, you can tell what the probability of finding the right information with only a subset of 1,000 queries a day is compared to 5 billion queries a day. Very, very difficult to find information. So we got to be more specific in how we search for our information, more repository specific. And these knowledge graphs will help us do some of that. Also, 30% of our total R&D is wasted duplicating work we've previously done. Quick story on that. A few years ago, we were testing the Orion capsule. And what we were testing was the uprighting system on the capsule. So when the capsule comes down and falls into the water, into the ocean, these big balloons will inflate and help the capsule to upright itself so the astronauts don't drown. Well, a few of those big balloons didn't work. So the organizations tried to look for information about the Apollo era because we had a similar uprighting system on the Apollo capsules. They went looking through our databases, couldn't find anything again because that was well over 50 years ago in some cases, and the information just wasn't stored correctly. We didn't index it, we don't have it. They went to the history office that had about 62 terabytes of data during the Apollo era in a very antiquated SQL system with keyword base. It took them hours and hours and hours. They went probably 3 or 4 days looking for information and found 3 documents. They went so far as to go visit retired engineers from that time frame, talk to them about what they did. Those engineers literally went up into their attics, brought down boxes of research. Here you go, good luck. That's the type of things we're facing because of the amount of data we've had for years and years ago. Fortunately, we were able to do some work with search algorithm, utilizing some things with knowledge graphs. We developed a system that allowed them to just look at that historical Apollo data we had, and through those algorithms we created, they were able to find information fairly quickly. Within 3 hours, they found 200 relevant documents. That's the kind of help you can see in knowledge graphs. But the last thing, the one that really gets me, is that 54% of our decisions are made with incomplete, inconsistent, or inadequate information. If we're making decisions based on half the information, that's kind of scary, especially the type of things that we do. So we got to improve about how we try to do those things. And how do I do that? Several years ago, I developed a framework that I call at NASA that I call knowledge architecture. And by that, I look at that as a combination of 3 different disciplines: knowledge management, knowledge informatics, and data science. Knowledge management is the strategy for how we identify, we collect, we create, analyze, store, and present our data. The knowledge informatics is the pipeline, those applications and tools and methodologies that allow us to transmit that data to our end users. And the data science, which has really become more and more popular over the last several years, is the methodologies, the algorithms, the methods we use in order to transfer that data into some form of actionable knowledge. I'm going to talk a little bit about all of that as I go through this scenario, and then show you how I've started to put that information into a knowledge graph that's going to allow us down the road to get the information even faster. And why is this important? Of course, this is another comment that I have from a former CEO of Google. We have an opportunity for everyone in the world to have access to all the world's information. This has never before been possible. It's ubiquitous information, so profound. It's a tremendous equalizer. Information is power. And here's where I play the semantic word. Actually, knowledge is power in my case. Having that information is great, but if you can't turn it into some kind of actionable knowledge, or if you can't really utilize it, if you can't find it, then it's not really worth it. So these type of tools and techniques that I'm going to show you will allow you to actually find that information to make it a lot easier. And it can be done from the smallest projects to the largest projects. I'm going to show you a small project. Why is that? It's because with great power comes great responsibility. You guys are responsible for looking at your information, looking at your data, and making sure that your end users can utilize it in a timely fashion. It's not so matter of finding that information, it's finding it at the right time when you need it. So, and how are we going to do that? We're going to turn our data into a graph. We're going to take these reams and reams of document type of orientation that I'll talk about a little bit, and turn it into a graph that shows us how we can connect the dots a little bit easier. So let me start with a little story first so I can give you kind of a background on what we're doing. Anybody recognize this picture at all? All right, so a few folks. Back in August of 2017, we had a solar eclipse. During that solar eclipse, this is what I call the greatest photobomb ever. The time-lapse photography of the International Space Station passing between the Earth and the Sun during that solar eclipse. So it's kind of one of the coolest pictures I think I like, and I kind of show it off because we're going to talk about the International Space Station here. So what we're trying to do with the International Space Station is we're going to demonstrate, and this is the data science portion of the solution that we're trying to derive here. They've got a huge amount of text within comments that have been given to us by the astronauts. And through that, we're going to look at the sentiment analysis, how we do the calculation and information extraction. I'm going to go through that very quickly. I said I put this presentation together really quickly, but I just want to show you, kind of give you a background of all of that before I actually show you a little live demo of the the knowledge graph that I want to show on that. So a little bit of background. Every time a group of astronauts come down from the International Space Station, they return to Earth, they get debriefed. And over the last 15 years, there've been a lot of debriefs going on. And we're not talking about a 30-minute conversation. We're talking 6, 10, 12, 15 hours at a time going over everything on the International Space Station, all about all the life, how was the food, how was the exercise equipment, what was the environment like, the exercises, the scientific projects you were working on. All of that needs to be captured so that we understand what life is like on the International Space Station so we can make it better for them. Because we just can't go up there and take a look at it and kind of do a home inspection. They're our eyes and ears while they're up there. So because of that, we've collected well over 80,000, well, now we're at well over 90,000 documents on that. And they get, like I said, they get debriefed on a lot of different things. So here's quite a quick picture of Karen Nyberg doing an experiment. I think she's doing some gene sequencing on the International Space Station. You can see the environment is very congested. There's got a lot of things going on, so we've got to figure out better ways to make it easier for them. Here's another image of a cosmonaut, a Russian cosmonaut, who's actually working on his laptop, I believe, but he's in the galley area. You can see somewhere up at the top there's a laptop kind of up on the wall. There's other equipment. It's not very easy for them to get around, so all the information we get from them helps us. And we have to be able to analyze that information that they give us a lot faster. Well, what's happening with this is that, again, we've got well over 90,000 comments now. I need to update this slide, which we equate that to about 90 copies of To Kill a Mockingbird. But we've got to get the astronauts' views. So what would happen is that once we've collected those, they, again, put it into a SQL database with very limited keyword-based search. So a question would come from one of the engineers or maybe one of the astronauts. What was a particular exercise equipment like? Well, maybe they're looking at the exercise equipment in its functionality. So they'll have to go in there in a SQL database, look up exercise equipment, and try to pull out all these comments, and a human factors engineer would read the comments. They would code them, they would theme them, they would write their notes on them, they would try to get them into different types of sentiment, trying to understand those. It would take them anywhere from 3 to 4 weeks to do that, just to try to get that little bit of information and put that out there. We were trying to help them, so they came to us to try to figure out what can we do. So we tried to start applying a little bit of data science, a little bit of analytics to that information. So we were going to take a look at sentiment theory on the text itself. And I'll go through this again pretty quickly. Utilizing an R package called QDAP, we were able to look at a particular polarized word and the words around it. So really quickly, for example, the polarized word here would be love. And we can decide based on we can tweak the algorithm to decide how many words around it we want to look at it. So in this case, ISS, the polarized word is love, and ISS is the noun it's applying it to. We get a score of 0.57. Or the reverse of that, I hate ISS, you get a negative 0.57. So you can see how the scoring works. You have things such as de-amplifiers and amplifiers, which raise and lower that. So I barely love the ISS, that de-amplifies love a little bit, gives you a little bit of a score. You have neutral, you have negators, so there's a way of looking at the words, the sentences, and the paragraphs, and actually give them a score that tells you how negative or positive, from a score of -1 to +1 on that rating. That information becomes essential metadata that you can add to your knowledge graph. One of the great things that I found about knowledge graphs like this, like a Neo4j graph, is that you have these properties you can assign to your entities. Not even to your entities, but to your relationships also, your edges. And those properties can be utilized to run further analysis. And I'm really excited to, when Alicia comes up and talks about her use of AI in some of these algorithms, because I want to see what's the next step we can go forward on some of these things. So here's the quick implementation of a paragraph that's showing you there. We detected sentences within that paragraph. We can give a score for each sentence within that paragraph. It is a -0.31 for the first sentence, a -0.19 for the second, and a +20. So that's where we're starting to break down and do the algorithms on top of the text to be able to give the human factors engineer an idea of what these comments are about, at least from a sentiment perspective. And here's a quick way of visualizing it for them. Darker red for more negative, lighter shade of red as it goes down a little bit, and then the blue for positive. Other variations of visualization on this come through from core diagrams. Again, this is just how we started. I'll show you how we're turning it in, now trying to turn it into a knowledge graph. Box plots do very similar, so there's a lot of different things you can do for visualization of these type of data. Bubble plots are very exciting because this starts to give us an idea, okay, how can we take this and then bring it into a knowledge graph? Here you've got a bubble plot. The size of the plot represents the level of sentiment. So the larger the bubble, the greater the sentiment. Of course, blue is positive, red is negative. And as you can see, your famous Latin words in that. I can't actually show you the comments. That I can't do, but I can at least show you that this is what it would look like for somebody that was going to read it. And then we can also do trend analysis. All of these things we're going to start being able to implement within a knowledge graph. We ran this through because a lot of the things we were doing here, we have a data scientist doing this. We'll eventually be able to develop stored procedures in the graph database that allow us to run this automatically for them so they can visualize it and get that information out a lot quicker. We can classify through this. And if we look at this classification, as we run through down at the bottom left over there, you see these three little, the circle around, the rectangle around those three comments there. If we look at those comments, they're all classified. They're all about some type of noise, some grinding noise or loud noise. So we're showing that the analytics is working. It's clustered. Again, more information to put back into your knowledge graph. And then we go look for information search and extraction theory. We're using a cosine similarity to look at the sentences and the words and how close they're related together. Again, more information we can put back into our graph database, and I'll show that example in a little bit as we go through here. And what it could do in this particular case, having put that, doing that cosine similarity and getting the term frequency, inverse document frequency, we can request a result from the data set that has a term nutrition. Well, as you can see, here's what the return came back. It talks about food warmer, ate well, eat everything. Not once did it have captured the word nutrition in that comment. Because of the cosine similarity, we said this word is close to nutrition, and it pulls up all of these words also, all of these sentences also. So those are the things you can do as you start applying these type of analytics into your text. So there's a paper written on it. That's the information there on the paper. That's my Twitter handle if anybody wants to reach out. That talks a little bit about it. But let me show you really quick the actual graph database to give you an idea that we're starting to develop this thing. So.